warm welcome, everybody, to the fourth and the last ACDH-CH lecture of 2021. So in the name of the Austrian Center for Digital Humanities and Cultural Heritage at the Austrian Academy of Sciences, it's my pleasure to welcome you all to this event. And the idea of this lecture series is to just give a short introduction where you're at. The idea is to invite international experts in digital humanities from various research areas to Vienna, at least virtually right now. We are in Vienna, and to bring them together with the DH community in Austria and beyond. And we're happy to actually be able to reach far beyond Austria by the virtue of this event currently being an online event. And so with that event series, we want to foster an exchange of ideas within the DH community on a transnational and an interdisciplinary level. So together with the invited experts, we would like to reflect and discuss the impact of digital methods in their respective fields. And today's lecture focuses on the field of digital art history. And we're very happy to welcome Hubertus Kohle and Stefanie Schneider from Ludwig Maximilian University of Munich as our invited lecturers. And in the spirit of bringing together the community, I'm also very happy that today's event takes place in cooperation with the Artist Austria, so the network for digital art history in Austria. And therefore, I'd like to welcome my dear colleague Anna Frasca-Rath as well from FAU University in Erlangen-Nürnberg, who is also the initiator of the Artist Austria network and who will co-moderate today's lecture together with me. And so with that, I hand over to Anna to shortly say a few words about the Artist Austria.
Okay, thank you so much, Florian. It is my greatest pleasure to take part in this event and to represent DARTist, the Network for Digital Art History here in Austria today. Those who are not familiar with the network, it has been funded in 2015 with a goal to connect everyone who works on digital art history here in Austria, and in order to initiate a dialogue between colleagues from various institutional backgrounds. So our founding members came from Austrian museums, from universities, from research institutes, and from all stages of their respective careers as students, established professionals, or postdocs and doctoral researchers. Since 2015, we organize one meeting every 3 months. And these meetings are always dedicated to different topics. One goal of these meetings is to offer a platform for networking. And therefore, the meetings are often dedicated to the introduction of ongoing or future projects in Austria. Then we organize moreover workshops, often in collaboration with cooperation partners, which are, for example, the Vienna Center for the History of Collecting, or the Austrian Society for Art History, or as today, the Austrian Center for Digital Humanities, CH. So I would like to grab the chance and would like to invite all of you to look at our website, which is www.darthist.at, I guess. And now I stop the promotion for our network, and I'm very happy to come today's lecture. And it is my greatest pleasure to introduce our first speaker, Hubertus Kohle, who for sure is well known to everybody in this audience and who might not need an introduction at all. Hubertus Kohle is professor for art history at the LMU, the Ludwig Maximilians Universität in Munich. And he is one of the earliest and for sure most established specialists for digital art history in the German academia. He has led several projects in the field, and I would like to refer only to the latest one, das Schwerpunktprogramm Das digitale Bild, a transdisciplinary research cluster founded in collaboration with Hubert Locher and funded by the DFG. It started in 2019. Kohle's large number of publications range from Diderot, Adolf Menzel to digital art history, and he's also well known to all students of digital art history for his pioneering publications on digital methods in art history. And I only want to refer to the most recent publications. For example, published in 2018, Museen Digital, eine Gedächtnisinstitution, sucht den Anschluss an die Zukunft. Or in 2013, Digitale Bildwissenschaften, and two other publications that were published this year in 2021, The Digital Image, a transdisciplinary research cluster, which was a special issue of the International Journal for Digital Art History, and was published in collaboration with Hubert Locher, and Die Zukunft des kunsthistorischen Publizierens, published in collaboration with Maria Effinger as well in 2021. So we are very, very pleased to welcome you as a speaker today and to learn more about the current outcome of your research. But before we will hand over the virtual microphone to you, I will hand it over to Florian again in order to introduce our second speaker, Stefanie Schneider.
Yeah, thank you, Anna. And it's my pleasure to introduce Stefanie Schneider. So she's a research associate at the Ludwig Maximilian University of Munich, working with Hubertus Kohle, and she is trained as a statistician and a computer scientist, and she has been working in digital humanities with a focus on data analysis in the recent years. And she also worked before in the area of film journalism for many years. And her research topics include digital art history, cultural analytics, digital film studies with a focus on genre theory, and research software engineering. And some of the projects she was involved in during the last years were, for example, ARTigo on social image tagging, the DHVLAB on the Digital Humanities Virtual Laboratory, Max Museum Analytics, for example, also the Citizen Science Project Stadt Land Bild, collaborating with, amongst others, the Academy of Fine Art in Vienna and the Laboratory for Cognitive Research in Art History at the University of Vienna. And also currently she's involved in the DFG-funded project iART, an interactive analysis and retrieval tool to support image-oriented research processes, about which our two guests will surely also speak today. And now I would like to hand over the floor to Hubertus Kohle and Stefanie Schneider.
Thanks a lot for the introduction and for the invitation, of course. With regard to the invitation, I might add for the audience, if you want to become the leader in a field, just look for a field where no one else or very few others are present, then you automatically become the leader in the field. But I will begin now. For a long time, the image did not play a particularly prominent role in the digital humanities compared to the text. This has only changed in recent years. There are now professorships for digital art history in Marburg, AI researchers in the field of the arts, for example, here in Munich. And I'm especially proud of that because we have Björn Ommer, formerly at the University of Heidelberg. And I might be able to say, since, and this should be true, I don't think that there's any other professor for for artificial intelligence in the cultural field, at least in Germany, but I would think it's even worldwide. Large image-oriented projects that are springing up like mushrooms in various places, even a priority program, I could skip that because this was already mentioned on the digital image. And above all, of course, there are the museums which have now finally discovered in pandemic times, although there have been moments before, of course, how important the digital can also be for their own power of impact. All too often, however, the computer is still used in art history as a simple container for digital reproductions of works of art. Relatively rarely is it also used as an analytical machine. In general, I notice that art history is sometimes all too anxious to chain down the digital to its own terms, or what it considers them to be, instead of letting go of the computers for once and playing out their own potentials, even if these point in an unusual direction at first glance. And I have to say, in the last 20 years, I always heard from my colleagues that whenever you wanted to use the computer for things which might not correspond exactly to what we did before, I always get warnings. But I would say we should try to find new things in it. With the undertakings to be presented here, and especially with the second part, we want to show, not the one that I'm going to present, we want to show how things can be done differently. We, in this case, by the way, means Stefanie Schneider and me, in that order. Everything that will be shown in the following would also have worked out without me, but definitely not the other way around. Honor to whom honor is due. I have to add, though, that Stefanie is a little ill today, and we will have to see how long she can drag on, but there will be some solutions to this. 13 years ago, at the suggestion and with the participation of my computer scientist colleague François Brie in Munich, we started ARTigo, which in turn drew on ideas from an American specialist in human computation from Guatemala, named Luis von Ahn, working at Carnegie Mellon. With ARTigo, we wanted to leave the annotation of artworks, for which we were able to provide a digital collection consisting of about 50,000 images, to the crowd in a playful process. And to date, this has resulted in close to 10 million tags, which we initially only made available for searching for works. And you see the search button up there on the right. The procedure still meets with standard criticism today, and that is, of course, the lay status of the players, which almost reflexively evokes the protest of the real or imagined art historical experts. From my wording, you see that I have suffered from many wounds, to say it in this way. At that time, however, which was in 2008, and most of you might not remember that, history has moved very quickly in the last years. 2008 is almost the last century. At that time, however, it was downright abstruse, also because of the novelty of the technical procedure, which by now has become somewhat more well-known, also with the influence of the social media. But I don't want to go into further detail here about ARTigo, which, by the way, is currently being brought into a completely new form by Stefanie and the computer science student Max Christen, and in my eyes, can also be used primarily as a museum marketing instrument, because ARTigo is only the prerequisite for what we want to present here. As I said, you can enter the 10 million tags into the search slot and find the corresponding images, often false ones, but again revealing precisely in their falseness. For example, now some words, although I just said I didn't want to go into ARTigo anymore, but I add that because I'm fascinated by that, and you can find many examples of that. For example, when you enter Napoleon, the computer also spits out portraits of people who definitely don't represent Napoleon, but who have their hand tucked into their vest in the way traditionally associated with Napoleon. And especially with these false annotations, you can have indirectly many deep-going cognitions and knowledges about art history. I think there will be a presentation at the next DH conference in Potsdam in March. However, if we treat the database as big data, remember the 10 million annotations, then we can also use these annotations for similarity determination. And this concept of similarity haunts me for years now. And I have to say, it's one of the most fascinating concepts in the sciences. This brings me to the point of interest here. In order to be able to do this, Stefanie Schneider, who has also already been mentioned several times and who will present the second part of this talk, has developed a so-called analysis center within the framework of our DHVLAB, in which she can measure different forms of similarities between works of visual art on the basis of the open source statistics software R. Just one sentence on the DHVLAB, although it has already been mentioned. This DHVLAB, here only in parentheses, is an environment that makes it possible to hold digitally supported seminars in the cloud. This has the advantage that one does not have to worry about comparable electronic prerequisites with the participants. The one has an Apple, the other a Windows computer, which result from different software environments. In this similarity analysis, to return to the starting point, we convert the tags assigned to artworks in ARTigo into vectors that have a certain direction and are compared in their sum with those of other artworks, resulting in their proximity or distance. A procedure, by the way, that for its triviality apparently evokes at best a wary smile in statistics. It has to be black now. It is not a fault. I will show you some results in a moment. While direct image addressing is radically formalistic and a pixel-based comparison is made, ARTigo is more iconographically oriented. This has to do with the simple fact that the participants usually annotate objects represented in images rather than naming the form in which this happens. The results are quite disparate, some incomprehensible, others convincing. In principle, I can compare individual pictures or artists. Especially the latter is unsatisfactory, but this probably has to do with the very unevenly distributed completeness of the coverage of these artists. Overall, I have to emphasize that the underlying image database has a focus on the 18th and 19th century, so it is affected by a massive bias. And I learned in the last years that these biases are one of the most fundamental problems of everything that has to do with artificial intelligence. It is better in the case of image similarities, so not of artist similarities. In the similarity analysis on the basis of a picture by Gauguin, for example, all of the front-ranked pictures are also by this painter or by someone who is also historically close to him, and I will try to demonstrate that in the following. The results vary according to the mathematical methods and weightings used, without it always being possible to say which one is more suitable than which other one. In the case shown here, Gauguin's Anna the Javanese from 1893, I showed it before, better and worse suitable methods seem to crystallize. In the binary projection, you see that on the left, without weighting, and if you afterwards ask what that means, we have our specialists who can try to explain that. 3 of the 10 most similar paintings are also by Gauguin, which I take here as an indication of the legitimacy of the comparison. Most of the others are at least not so far away historically, and I recall this is only based on mostly lay person annotations. Only the last one is somewhat more distant from the other results, but this outlier is quite plausible since it shows a view of a naked sitting woman, albeit painted in a considerably cruder manner, and it was created 100 years later, namely by the British contemporary artist and Turner Prize winner Jenny Saville. With normalized search word density in combination with entropy, 5 of the 10 most similar are already by Gauguin, and the outlier has disappeared. The normalized search word density together with the inverse document frequency performs best. Here, except for the most similar one, ausgerechnet, for the most, for the most similar one, Corinth, all others are by Gauguin himself. One has to ask, however, and that is the epistemologically difficult question, what in this context good and bad result means. I measured it by my expectations, which are mostly historically coined, and I'm happy to find a whole series of other Gauguins. Are perhaps just those results interesting which do not correspond to the expectations because they reach into new areas? However, I would like to add here, without answering to this question for the time being, I would like to add here already that the procedure proves, after all, the wisdom of the crowd, which one can use in any case for the filtering of large image sets. By the way, the same applies to an alternative method, which runs under the rubric of unsupervised learning. Here it is left to the computer to use the annotation data available to it for an independent clustering of the entire image set, which is the 50,000 images. The resulting groups correspond to classical genre classifications, but also go beyond them in some places and generate classifications that seem to make sense, although surprising classifications are made in them. I don't want to go into details here. From this point of view, the results are similar to those of the work similarity analysis. On the one hand, the expectability of the results, which result from the, that's a bad translation, which result from the accuracy of fit in traditional criteria, can confirm the legitimacy of the method. On the other hand, it should also be considered whether the unexpected results are not the more valuable ones, for they point to objects that go beyond the common and for that very reason might have an innovative effect. Another example to complement the Gauguin picture, Jacques-Louis David's Death of Marat, an icon of French revolutionary art, which I will show you in a moment. This painting has received 223 individual tags in ARTigo, slightly more than the average image. A vector-based comparison of these tags again shows the works that are most similar to the image. Based on keyword density and entropy, 87% of similarity shows the same image, but in a different reproduction. And you see in the second row, Joseph Roch, which is this painting. But in a different reproduction. No, this was, of course, I have, this is wrong. Of course, this is the different reproduction of the same image. Sorry, I confused it and I destroyed my point, I'm afraid. You have an 87% similarity with the same image, but in a different reproduction. This will not be surprising, but it is quite lucrative in applications. For example, for the organization of image databases, because in this way you can identify all the doubles, triples, and quadruples, which, for example, is a problem in Prometheus, which you might all know. And in this way, you can exclude them from your database or arrange them in a lower register. More is interesting than the following work, are the following works. That the next most similar is a competing Marat representation by Joseph Roch. And considering that this identification is not done by the image name, but by the multitude of descriptive annotations, its potential becomes apparent. I repeat that. The annotations did not say Marat. The annotations just described the painting, which led to a high rank of similarity to David's painting. This is not based on the individual indications, I repeat that again, but nevertheless on their combination, and is an instructive example of an emergent phenomenon. I don't know if this is, I didn't find a better translation in English. It is what we in German call emergence. It's not emergency, that's something different. The following portrait of a writer, which I do not show, can at least provide a hint to the sphere of meaning of David's Marat, even if it is otherwise rather doubtful in our context. The same applies to other things that can be seen here. After all, Goya's Jovellanos could suggest the affinity of two lonely human friends, and apart from the fact that they are both almost identically dated, Courbet's Wounded Man, which is also high in the ranking of similarity, could refer to the intellectual's willingness to sacrifice, and the strangest one, Artemisia Gentileschi's Judith Kills Holofernes, could designate an iconographic resonance space to which David's image also refers. All three of these authors appear in the list of the most similar works, and I show you again. What is the whole thing supposed to be usable for? I myself like it so much because it obeys exactly the conditions I set for fruitful procedures of the digital humanities. These seems to me to fit hermeneutic approaches, especially where they can be used as recommendations, as pointers, as indications of places in need of explanation. On the one hand, this does not destroy the autonomy of humanities procedures. It integrates meaningfully quantifying procedures into our spheres without us having to give up our identity as humanities scholars ourselves. And this is something which most of my colleagues fear to be, which they normally transfer or convert into irony and laughing. But there is a certain fear behind that. In the case of the similarity analysis presented here, this means that researchers are provided with comparative material that can trigger cognitive processes. The comparative specimens, if they are to trigger these processes, would have to be sufficiently similar to be the starting point, but also sufficiently dissimilar to overcome the boundaries of the known. Figuratively speaking, two cables through which the electricity current flows should be held so close to each other that the spark jumps over. The crucial point here is that this very point cannot be reached in a controlled manner, but that chance plays a role in it. This seems to me to have a lot to do with what has been going on since Horace Walpole's famous statement under the catchword of serendipity. For systematic reasons, serendipity cannot be forced, but one can always give it new nourishment by feeding it material that, to remain in the aforementioned image, makes the sparks fly. This is exactly what happens in an analysis center like the one described. In an iterative procedure, the various mathematical procedures must be gone through, and differently weighted combinations of metadata must be applied in order to provide the researcher with the objects that might possibly take him or her further. It can be shown that this is not one particular mathematical method that is always the best, but that you have to go through all of them. The crucial thing is the openness of the approach, which excludes certain results. But as I have learned, this is a characteristic of the sciences in general. And it identifies digital humanities procedures, at least at this point, as an auxiliary science, a designation that often passes for an insult, but for me is a compliment. And let me add one further sentence in order to clear the point. As you saw my comparisons, which were the most similar ones, the problem with that is it is very different from our normal argumentation. In our normal argumentation, we try to close the argument, to finish it by giving a proof. What is done here is you don't prove anything. You only give recommendations. You open a process. Something might be completely idiotic, some of the comparisons, but some of them, and this only depends from your own approach. And this is your individual approach. That's why it is so difficult to evaluate that. Some of them might give an inspiration to you. And this is an uncontrolled process. All the more interesting, it seems to me. Incidentally, and that's my last part, if I am too lengthy, now we are, I think I can add that. Incidentally, such similarity determinations can of course be carried out not only for images, but also for texts. The aforementioned employee, I didn't want to repeat the name Stefanie Schneider again, also tried this and was inspired by the well-known plagiarism software. This sounds destructive, but something like this can also be used productively in this field. Between 100% similarity, which is identity, and 0% similarity, which is maximum difference, intermediate levels can be defined, the usefulness of which would have to be developed empirically out of sheer desperation, because I couldn't think of anything else to say about the requested topic. And you are mostly asked to give a contribution to a conference, for example, on the basis of your own contributions, but then they always think you can find something new. That was my desperation. But I wanted to take part in that conference. I remember that was in Cambridge, and who could ever refuse to go to Cambridge? I copied it down from an own publication and added a few sentences around it corresponding to the occasion. The result was 85% similarity to the other text. Interestingly, 85% is also the value that indicates in an ARTigo analysis, you remember the Marat case, that it is the same image, only in a different reproduction. That might be by chance, but maybe it is significant. But I'm not interested in plagiarism detection, but in the identification of texts that, as just described for the images, are sufficiently similar, but also sufficiently dissimilar to make the spark fly. That is perhaps 50 or 60%. It seems to me that something like this is quite useful for repositories with huge amount of machine-readable full text, for example, because it gives interested people suggestions for reading that serve their own research question, but at the same time go beyond it. And you all know the library catalogs, which sometimes or often now recommend you the reader, as in Amazon, the reader who lent this book was also interested in these other books, but this is only based on metadata, and maybe libraries should reflect about doing this on the grounds of whole text analysis. And this is the end of my part, and the more important one, and I do not say that for reasons of fishing for compliments, the more important one is following now. And I pass over to Stefanie Schneider.
Thank you. And in the following section, we turn away from this metadata-driven approach and towards search based on artificial intelligence. So well, we will see how that works out. We focus here on a tool called iART, which was already mentioned and has been developed over the past 3 years as part of a DFG project. Involved were the chair of medieval and modern art history at LMU Munich, the research group Visual Analytics at TEB Hannover, and the research group Intelligent Systems and Machine Learning of the Heinz Nixdorf Institute at the University of Paderborn. iART, short for Interactive Analysis and Retrieval Tool, is basically a browser-based search engine specifically tailored to the analysis of art historical image databases, as is already indicated by the art in the name. Unlike ARTigo, it supports multimodal search, that is search based on text or image input, or in this case, multiple text or image inputs, each of which returns similar objects. However, users can control their search concerns much more precisely. Not only can search include both image and text, individual query components can also be set negative, for example, to erase unwanted results or to filter certain focus areas. Furthermore, each query component can be weighted, and in this way, the similarity to be considered can be set. That's a bit like the analysis center shown before. For this purpose, we implement deep learning methods. That's what is used to be calling artificial intelligence. And these deep learning methods in the back end ensures results are only returned if they are particularly relevant to the search query in question. In other words, we do not search based on metadata. That's very important here, as was previously the case. I'll come back to this in a moment. Before that, a short example by way of introduction. For orientation purposes, the positioning of the individual components in iART is classic. The familiar search slot is at the top center, as you can see here, while advanced setting options appear in a banner below. Some of them, like the different result views, I will introduce successively later on. And again, we begin with a search, here a text-based search, but again, it's not metadata-based for def of Marat. And we see 4 relevant groups of results. Firstly, Jacques-Louis David's def of Marat in many reproductions, plus other examples of this iconography. Secondly, examples of representations of the dead Christ, to which the Marat representations also refer. Thirdly, other figures that have their arm hanging down in a similar way to David's Marat and would likewise need to be examined to see if there's a line of connection to David's image. And fourthly, completely different iconographies that could be formally related, for example, in the arrangement of the curved line that is formed in the image of David by the posture of the dead man. For instance, the fourth image from the left shows a vegetable. More precisely, it's a cardoon, the so-called Spanish artichoke, which is arranged laterally similar to the dead Marat in his bathtub. On Google, just as a prominent counterexample, on the other hand, we see countless reproductions with frames in museums as stock photos, detail views. There are modern remakes, memes, all obviously classified as relevant because the metadata contains def of Marat, although of course we don't know that for sure. What we see here is that content-related iconographic as well as radically formalistic searches are almost impossible because Google focused solely on identity-related representations and not like iART, also on those that could be declared similar in a broader sense. And this even applies if a reproduction of David's Marat is used in an image search. The differences in the results are due to many factors, which I can only describe in extremely condensed form here due to time constraints. But in my opinion, 2 of the most important ones are the data used for training the algorithms in the back end and the extraction of not only one, but several representations of an image, mathematically speaking, so-called embeddings, which can here be flexibly combined. Generally, search engines expect a single representation of an image that is used for all search queries, no matter how differently targeted research question may be. However, as we have seen in several workshops that we hosted in the context of the CFG program, art historians need to find objects according to different aspects of similarity, such as composition, color, or iconographic criteria, as we've already seen. Therefore, iART generates a large number of features per image, which can be weighted with sliders according to the interest of the researcher. The underlying system was developed to be as flexible as possible, so they can easily extend it by plugins, as you can guess from the shown pipeline here. Each plugin is usually based on a different training data set, which is suitable for the respective model. For example, due to the metadata provided. So the metadata is relevant in the context of this training process, actually, but not in the search in the front end. Currently implemented are, among others, I'm just presenting 4 of them, an IMAT classifier that was trained with data from the Metropolitan Museum of Art and contains over 3,000 tags. For example, for region, culture, and medium. Additionally implemented is a classifier trained on WikiArt sample that predicts 40 genre and almost 150 style categories. And the keywords assigned to an artwork are also displayed online in the detail view of the object, as you can see in the screenshot here, with an icon behind each tag indicating the respective classifier. I would like to go into more detail on 2 models. First, BYOL, that's a short for Bootstrap Your Own Latent. And it is a self-supervised learning method for neural networks that is to optimize a model based on this technique. No annotations are needed for the individual images, unlike the 2 classifiers that I've shortly introduced before. The goal during training was that 2 details of the same image should be similar in feature space than details of other images. In the background, you can see the corresponding selection window in the upper left corner. That's this thing here. With sliders and advanced setting options. Currently, we distinguish between color and more content-based features, which can be directly addressed by the user. Among them is also CLIP, one of the most well-known neural networks, although it was only released in January this year. It includes models for visual and textual information trained using several million image text pairs. And the goal of the training here was to ensure that visual and textual representations for an image text pair and not details of an image are as close as possible in the feature space. Due to this multimodal orientation, we use it in iART in 2 ways. First, search queries can be transferred to the image space using the text model. This allows users not only to search for expected tags or metadata, but also to describe images directly, as I showed with the Marat example at the beginning. The results of which I would like to emphasize this here again, were not based on metadata. On the other hand, the model can use a zero-shot approach to predict textual keywords without having been trained with them. And we use this approach to generate 20,000 notations of the icon class classification systems. And to name just one example, here with Cranach's Adam and Eve, this works surprisingly well. The image is classified relatively reliable under notation SEM1A4, where you can find everything about temptation and the fall of man. Before I present 3 exemplary queries, some key data on the collections displayed online, which are exclusively openly licensed. Currently provided in the front end are data from 5 art historical relevant sources, which can also be explicitly addressed via a faceted search, as you can see in the selection field here in the bottom right. We include data of the Dutch Rijksmuseum with 400,000 objects, of Wikidata with 350,000 objects, of the virtual coin cabinet Kingdom with 100,000 objects, naturally of ARTigo. And we also have a small set from the museum portal Kulturerbe Niedersachsen with 12,000 objects. To ensure that more specific questions can be addressed flexibly, iART also allows registered users to import their own data if they have a scientific research concern. That's the only limitation here. All that is required is to upload a zip file with the respective images. You can, of course, also include metadata, but that's optional. And then users are able to examine their important collection individually or in context of the freely available content that I have just shown. And I think the advantages of iART are particularly apparent for search queries that were previously almost impossible due to their semantic complexity, or that only produced meaningful results in extremely fine-grained keyworded systems. We see 3 application scenarios I would like to describe in the following with examples. First, search for similar iconographies. We begin with an image query of Da Vinci's Salvator Mundi that leads to a number of Salvator depictions, among which only few other iconographies are mixed. Above all, objects are found that are labeled differently, for example, in another language. And if we go a step further, and cluster with k-means. This also contributes to a further specification of the result set. For example, we can here see in cluster 4 that this contains predominantly drawings, copper plate engravings, and woodcuts. By the way, something similar is noticeable in the search for too much alcohol. That's one of our favorite search queries. There he, that is the neural network, finds drunks, but also a number of depictions of the dead Christ, for he hangs around similarly uncoordinated as the drunks for obvious reasons. A clustering here, in turn, neatly separates the simply drunk from the dead, and we can also see the separation in the 2-dimensional view, even if I don't zoom in here. A second example, search for similar motifs. Hubertus deals with Menzel's Marktplatz in Verona for publication, and in this context with representations of markets. And an analysis of an image query yields those market scenes, but interestingly also depictions of crowds in other contexts, that is battle depictions, historical scenes of crowds, general street views, strike scenes, revolutionary scenes, and so on. So on the one hand, I find exactly my constellation of motifs with the markets. On the other hand, the system provides me with something like a superordinate category, which could perhaps be described best with the term crowd. What is interesting here is that many of the similar pictures are from the same historical epoch, that is the second half of the 19th century. And several questions arise. Could this be a period style here? Is this the artistic expression of the mass society that began in this very period? Or is it just a data bias because of the data sets or algorithms we used? The third example, search for similar image types. And again, we use a query by image search, in this case with Tizian's Jacopo de Strada, that results in a series of half-figure portraits whose protagonists are mostly fur-trimmed, and in many cases date to the second half of the 16th century. All three phenomena could turn out to be helpful. First, it identifies the type of half-figure portrait that can be addressed with traditional procedures only when a record has metadata worked out in detail. Second, fur as a cloak, as a stole, etc., is identified as a garment that is considered a social mark of distinction, thus limiting the range of works found to an audience. And thirdly, again, the temporal restriction gives an indication of the apparently particularly frequent occurrence of this type of image in the late Renaissance. What these application scenarios show, I think, is that iART can serve as a supportive tool. That's the important thing here. It's supportive for art and cultural studies research by firstly identifying, secondly, it's extracting, and thirdly, analyzing image objects of interest for a research question, and always actively involving the user in the search process. In principle, this machine-based search should also, like the search in ARTigo, be understood as an incentive for the exploration, and in my opinion, not as an instrument that delivers perfect results per se. We think that precisely through such results that initially appear nonsensical or obviously wrong, like the cartoon in the beginning, that research perspective that require closer examination can emerge. And you can all try this out, either at the moment or later on. And I now thank you very much for your attention, and I look forward to your questions.